All right, honors pre-calc today, we're going to be starting 2.3, polynomial and synthetic division. This is the third of 7 lessons in chapter 2. Here's what we're going to do today. You will be learning to use long division and synthetic division to change a standard form polynomial into its factor form. And you will use the remainder theorem and factor theorem to determine if a divisor is a factor of a polynomial. So we're going to learn about polynomial long division, synthetic division, and then we're going to learn these two theorems, the remainder theorem and the factor theorem. The essential question today is, how do you use polynomial dividing techniques to find factors of polynomial? And you should already know what a polynomial function is. Remember, that's just, we have monomial, binomial, trinomial. Polynomial just means a function with just x terms raised to certain powers, and they're all added or subtracted, all of the terms are, and there can be any number of terms. Poly means just like multiple, right? So it's not saying there's a specific number of terms, it's just some number of terms that have x's that are raised to certain powers. And we also need to know normal long division of integers. So how do you do long division back from most likely elementary school, right? And we're going to do it a specific way. I know that you might have learned how to divide in multiple different ways back in elementary school, at least if you went to Carlisle. So we're going to see a specific method to it that will help us as we use long division for polynomials. All right, so let me switch over the screen here. All right, so we're going to start out here with two simple long division questions. I already have them set up here on this notebook paper. If you can just find somewhere to write these down, that would be perfect. That can be on the side of your notes somewhere if you can squeeze it in, but it doesn't matter. And you don't have to worry about taking pictures of this to submit it with your notes. We're going to try two questions, and I'm just going to have us walk through and think about the steps every time, because those steps are going to come back in a minute when we get to polynomial long division, okay? Just to give you kind of a preview, you can see on this worksheet that we're going to be doing something very similar to long division, except with x's, okay? I can also tell my video is lagging, so I'm going to pause for 1 second to fix that. All right, let's see if the camera will keep up with this time, with us this time. So let's try this. So we start off over here and we say, this question is 1,395 divided by 5. And we say, how many times does 5 go into 1? All right, well, 5 doesn't go into 1. So we immediately expand to think about 13. We say, how many times does 5 go into 13? And the answer would be 2. So we line up a 2 above the right side of the 13, so above the 3. And the next step is we do 2 times 5. We get 10. We write it directly underneath the 13. And then we have to subtract from the 13. So 13 minus 10 is 3. We bring down the 9 and we start over. All right, and maybe this is something that you already have completely mastered and you remember all of it. Great. Hopefully that's true for many of you, but we are going to walk through these steps because, again, they're going to come back. So 5 goes into 39 7 times. 7 times 5 is 35. We subtract that, and we get 4. Then we bring down the 5, and then we start over. 5 goes into 45 9 times. 9 times 5 is 45, and we get a remainder of 0. We ran out of digits to bring down, and our remainder was 0. So that means that our answer is 279. All right? We're going to do the same thing over here in this question. 9 goes into 9 1 time. 9 minus 9 is 0. We bring down the 2. So 9 goes into 2 0 times. So in this case, since we're in the middle of the question, we have to write a 0 up here and then bring down the 3. Okay, so 0 times 9 is 0. I could go through the steps of showing that 2 minus 0 is 2 and then bring down the 3. But usually we just skip that part and we immediately bring down the 3 because this one was 0. So now we say, how many times does 9 go into 23? That would be 2. 2 times 9 is 18. We subtract, and we get 5. We bring down the 5. Then our cycle starts over. 9 goes into 55. 6 times. 6 times 9 is 54. We subtract and we get 1. Then we bring down the 6. 9 goes into 16 one time. 1 times 9 is 9. We subtract and we get 7. And we ran out of digits to bring down. So this time we have a remainder of 7. And way back in elementary school, there's a couple of different ways that you could have learned to do this. Sometimes you just write R7, right? So the answer is 10,261, remainder 7. For our sake, for this notes, we're going to write it as a fraction. So we could write 10,261 and 7/9, right? We always put it over the number that we were originally dividing by. So this question's answer is 10,261 and 7/9. Okay? So that's a little bit of a review of, long division. Now we're going to apply it to polynomials. So let me pull out the notes over here. Polynomial, long, and synthetic division. Okay, so here we go. First of all, we've got our division algorithm, and there's all sorts of crazy stuff going on over here, but really the important thing is that we have 3 vocab terms that we need to know. We need to know divisor, what we're dividing by, the quotient, which is the result, and the remainder, which is what's left over, right? Synthetic division, we're going to learn about later on in the notes, as well as these 2 theorems. But let's just get right into the long division. So we're going to use long division to divide the following polynomials. First up, 6x cubed minus 19x squared plus 16x minus 4, and we're dividing that by x minus 2. So I do encourage you to write fairly small here because we are going to need a lot of this space. But let's start out. We are going to write this just like we would write normal long division, except we're writing a full polynomial in here. So we're dividing by the x minus 2, but I'm going to write 6x cubed minus 19x squared plus 16x minus 4, and that's going to go inside the long division symbol. We're dividing by x minus 2, so we write that out in front like this, and then we start, okay? And it's very similar questions as to what we would have been asking when we do integer long division, but we have to kind of adjust each step. So the first question is, we just look at the first term of the divisor, what we're dividing by, and the first term of the original polynomial. So, and we say, what do we have to multiply by x to get 6x cubed? All right, our goal is to do something times x to get 6x cubed. It's another way of saying how many times does x go into 6x cubed. So what do we multiply by x to get 6x cubed? The answer would be 6x squared, right? There's no coefficient out here, so we do have to include the 6, and there's already 1x, so we need 2 more x's. So it's going to be 6x squared, and now I have to think of each of these kind of placeholders as for the x cubed terms, the x squared terms, the x terms, and the constant terms. So if I'm getting 6x squared, I'm going to write it over the x squared term, like that. So how many times, or what do I multiply by x to get 6x cubed? It's 6x squared, and I write it above the x squared term. All right, now I kind of multiply 6x squared by x minus 2 and write it under here where it goes. So 6x squared times x is that 6x cubed, and I write it under the x cubed terms. 6x squared times negative 2 is going to be negative 12x squared, and I write it under the x squared terms. Okay, so I had to distribute the 6x squared to the x and to the negative 2, and then write it down here. Now, just like in normal long division, I'm going to have to subtract this line from the one above it. Okay, so 6x cubed minus x cubed is 0. And this is where this gets tricky because it's easy to lose track of this negative. That is negative 19x squared minus negative 12x squared. So something you might want to do is distribute the negative throughout so that you don't lose track of it as we're going. So we do negative 19 plus 12 is going to be negative 7x squared. And the last step before we kind of start over the cycle is to bring down the next term, plus 16x, just like we did with long division, okay? I'm going to switch colors here as we keep going, and we're going to start over. So we ask those same series of questions over and over and over. So now I say, what times x gives me negative 7x squared? The answer would be negative 7x. So now I multiply just the negative 7x times x, and then times negative 2, and write it under here. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. Then I'm going to subtract that line from the one above it. To keep things clear, I'm going to distribute the negative. So we have negative 7 plus 7 goes away. 16 minus 14 is 2x. And I'm going to bring down the next term, minus 4. I'll switch colors again, and we start the cycle over. So now we say, what times x gives me 2x? That's going to be a positive 2. So now I distribute the positive 2 to the x and to the negative 2 and write it under here. So 2 times x is 2x. 2 times negative 2 is negative 4. We subtract. And this time we have 2x minus 2x, negative 4 minus negative 4. So we get 0. Right? If you wanted, you could again distribute this negative just to be sure that you don't forget to. And we get a remainder of 0. So our answer is 6x squared minus 7x plus 2. Okay, we're going to do 2 more examples, and there are a couple extra things that pop up each time. In letter B, we're going to do x cubed minus 1 divided by x minus 1. So in this question, the idea of placeholder 0 terms comes into play, okay? So that's going to be something in letter B. When we write this in our division context, x cubed minus 1, we're going to have to realize that there's no x squared term and there's no x term between the x cubed and the 1. So not only do we want everything to be in order when we write it out, but we want to make sure that we have some sort of placeholder for everything. So I'm going to write x cubed plus 0x squared plus 0x, and then the minus 1. Okay, so we have to have a placeholder for the x squared, a placeholder for the x, because we don't know what's going to pop up on top yet. We might need somewhere to hold that. So just like if we have a 0 in the thing that we're dividing in integers, like if we divided by 1054, right? You need the 0 for the hundreds, 1054. You can't just leave it out because it's 0. Just like that, in long division of polynomials, we want to include zeros for the terms that are missing. And we're dividing by x minus 1. Okay, so we start the same process as we did in the previous question. Hey, real quick though, if this skipped a term, we would also have to write a placeholder 0 in the divisor. Okay, it doesn't only apply to these numbers, it might need to be over here too. So placeholder 0 can be in this or in this part of the question. Okay. So now we say, what times x gives us x cubed? And the answer is x squared. Good thing we put that placeholder 0, because now we have somewhere to put an x squared term on top. And now we do x squared times x squared times negative 1, and we subtract. I'm going to distribute the negative, and that cancels out. We're left with 0 plus 1 is 1x squared. And we bring down the plus 0x. Yes, even though it was a 0 term, we still bring it down as the next term. I'm going to switch colors here and start the process over. What times x gives us x squared? That would be 1x. X times x is x squared. X times negative 1 is negative x. We subtract. Distribute the negative. The x squareds cancel out. 0x plus x is x. And I bring down the minus 1. Switch colors again. What times x is x? And it is 1, right? 1 times x is x. So now I keep going. 1 times x is x. 1 times negative 1 is negative 1. I subtract. X minus 1 minus x minus 1 is going to be 0. Okay, so we got a remainder of 0. And we have our quotient, the result of the division, right up here. X squared plus X plus 1. Okay? Now, I do want to tell you that one other way of thinking about this before we move into the next question is that, think about that x cubed minus 1, that original thing that we divided. Now that we divided out x minus 1, we're left with x squared plus x plus 1. So one way of writing x cubed minus 1 in a factored form is to think about, okay, we divided out an x minus 1 and got this. So that means that the x squared plus x plus 1 times x minus 1 must be the original x cubed minus 1, right? That's like saying that division is the opposite of multiplication. It is. So we factored out, by dividing x minus 1 out, we factored it out and we're left with this. Okay? That's going to become something that you're going to need to be able to use on the worksheet for this. But let's move into letter C. All right, same idea. Do I need any placeholder zeros this time? We have an x to the fourth, third, second, first, no. Second, first, nothing. Nope, no placeholder zeros necessary. So I'm just going to write this out. We do have the most terms we've had yet, though. But I'm confident that we can master this and handle this. Okay. So let's try this. So we say what times x squared gives us 2x to the fourth, and that would have to be 2x squared. Okay, so we skipped 2 terms this time. It's all the way over here is the 2x squared term. Remember, I always want to write it directly above the other x squared term. Then I distribute the 2x squared to all 3 of these and write it underneath. So 2x squared times x squared is 2x to the fourth. 2x squared times 2x is 4x cubed. 2x squared times negative 3 is going to be negative 6x squared. I want to subtract all of this. So I'm going to distribute the negative, and we'll get nothing, nothing, and 1x squared. Okay. So now something weird happened. We canceled out 2 terms at a time. So if that happens and you cancel out 2 terms, that means, lucky us, we get to bring down 2 terms at once. Another way to think about that is that since our divisor was 3 terms, we're always going to need 3 terms down here in order to perform the long division operation. So since we only were left with 1 term, we can bring 2 more down so that it matches what's up here. But now we say what times x squared gives us x squared? Well, that's going to be 1, right? And the 1 actually lines up with this term over here. So we have a plus 1. We kind of skipped over the 3x. There's no x term to go up here. But that's okay. Our quotient, our answer is just going to have to be 2x squared plus 1, just no x term. So now we distribute the 1. We get x squared plus 2x minus 3. We subtract, distribute the negative, and I get x plus 1. All right, so we ran out of terms, and I can't say what times x squared gives me x. Nothing times x squared will give you x unless you consider kind of fractions, but we're not going to get into that. This is just what's left over. So this is our remainder. And so how we're going to write the final answer is to think about the quotient, 2x squared plus 1. And then we add the remainder divided by the original divisor, x squared plus 2x minus 3. So that's our final answer. Just like long division with integers, remember that last question was 7/9. It was 7 over the 9 because 9 was the divisor. Same idea here. X plus 1 is over what we divided by because it didn't get a chance to be divided by that. All right, so we have 2x squared plus 1 plus x plus 1 over the divisor. This plus right here is super important. Oftentimes students will be writing this out and then they'll just write the fraction next to it and forget to write the plus. If this plus was missing and you literally just wrote 2x squared plus 1, x plus 1 over x squared plus 2x minus 3, that in math notation means that you're multiplying, right? If there's no operation written, multiplication is assumed. So that's like you're multiplying the 1 times this. But then what happened to the +1? Like we still need the +1. So this plus is really important. Do not forget it. This is how you write a remainder. Okay? All right, with that, we are going to move into synthetic division. I'm going to flip the page over here. Now, synthetic division does the same thing. The answer will still be the quotient, but it kind of simplifies the process. And I will say that there are a couple different formats to write synthetic division in. I always write it a specific way. I know some other teachers, I believe that Mr. Campbell writes this in a slightly different way. I like the way that I write it better. Nothing against the other way. There's just different preferences, but this is what I'm going to do. If you know it a different way, I encourage you to try this way, and then maybe you can go back to the other way later if you like it better, but at least try this. So here's what we're going to do. We're going to use synthetic division to divide these polynomials. So synthetic division has kind of like an extended L to start. And there needs to be 2 rows of numbers inside. So make sure there's room for 2 rows of numbers. And what I'm going to do is I'm going to write the coefficient of each term in the top row inside the L. So the x to the 4th has a 1 as its coefficient. Now there's no x cubed term. So we need a placeholder 0 for the x cubed. The x squared has a -10 coefficient. The x has a -2. And a constant is 4. All right, so there's our top row of our synthetic division. We're dividing by x plus 3. So the next thing we need to do is write a number out to the left of the L. And what we always do is we set the divisor equal to 0. And whatever x equals, that's the number that goes out here. So x plus 3 equals 0, x equals -3. If it's just an x plus or an x minus, it's always the opposite sign goes out here. So we're dividing by x plus 3. The 0 is -3. So the -3 is what goes out here. It's always like the 0 or the x-intercept that's a result of that factor. But we'll talk more about that later. So now we're going to bring down the 1. So the first step is always bring down the first number to the bottom. Okay? You never multiply that by anything, add anything, you just bring it down. So we brought down a 1. Then we do 1 times -3 and write the answer in the second row of the next column. So we do 1 times -3 is -3, and then we add down. We get -3. We do -3 times -3 is 9, and we add down. Then we do -1 times -3, that's 3, and we add down. Then we do 1 times -3 is -3, and we add down. Okay, so it's really just the same couple steps over and over. You multiply and you add, and you multiply and you add, okay? After that, I like to label what each of these numbers represent. We're almost done already. This last number, whatever the last number is always the remainder. Then you have your constant term, and then you have you just kind of go up by 1 exponent each time. So we have our x term, our x squared term, our x cubed term. And then the last thing we're going to do is write it out. So we have 1x cubed minus 3x squared minus 1x plus 1. And then we have a remainder of 1. So don't forget to write that part. And we have to write plus, just like when we did long division, we do plus 1 over what we originally divided by, the actual x expression, not just divided by -3. We write the whole divisor over x plus 3. Okay, so that is how we do synthetic division. Synthetic division only works for a linear divisor, meaning it has to be just an x to the first power. If we have something more complicated, like we did in letter C on the front page, you had an x squared. We wouldn't be able to use synthetic division for that. We could have used it for this and for this because we're dividing by a linear factor. Okay, let's look at letter B. We're going to do the same thing. So I'm going to set up my L. On the top row, I have 1x cubed, 3x squared, negative 64x, and negative 64. X plus 1 means I put a negative 1 on the outside. And then I bring the 1 down, multiply by negative 1, add down, multiply by negative 1, add down, multiply by negative 1, and add down. Then we have our remainder, our constant term, our x term, and our x squared term. Every time you do this, as you can see, the degree should be reducing by 1 from the beginning to the end. Our final answer, though, is 1x squared plus 2x minus 66 plus 2 over the original divisor, which was x plus 1. There you go. Okay. We got two more things to look at here, the remainder theorem and the factor theorem. If we go back to the front page, let's take a look at what those are. The remainder theorem says if a polynomial is divided, the remainder is r equals f of k. Okay, so what does that mean? Well, let's think that through. If the polynomial f of k is divided by x minus k, the remainder will be r equals f of k. F of k means whatever is subtracted right here, we plug into the original function. We'll get a chance to look at that now. So let's try that. So we're going to evaluate the following function at x equals negative 2. So we're going to do this in two different ways. What's really being requested here is what is f of negative 2, right? If we're being told to evaluate a function, we are told to plug in negative 2, right? So one thing we could do is just plug in negative 2. That's not really any special theorem, that's just math. But if we plug in negative 2, we will end up with 3 times negative 8 plus 8 times 4 minus 10 minus 7. It ends up being negative 9. So negative 9 is the value of the function at x equals negative 2. But we could also do this using the remainder of the synthetic division. So if you plug in the numbers necessary here, 3, 8, 5, negative 7. And if we're going to evaluate at x equals negative 2, that's the number that we're putting out here, right? So if you think about that, this, if we wrote it in factor form, it'd be x plus 2 equals 0. If we solve that for x, that's what would get the negative 2. So we know we are plugging in the negative 2 here in the synthetic division. We bring down the 3. 3 times negative 2 is negative 6. We bring down, or we add and we get 2. 2 times negative 2 is negative 4. We add down. 1 times negative 2 is negative 2. And we add down. And what you should notice is that the remainder is the same of the value of the function at the same x value. So the remainder was negative 9. The function is at a y value of negative 9. So negative 2 here, negative 2 there, negative 9 there, negative 9 there. And that's going to be true for any polynomial divided by a linear factor, x plus something or x minus something, okay? Pretty neat, I would say. And that brings us to example 4, the factor theorem. So the factor theorem is a more specific version of the remainder theorem, saying that let's say that that remainder was 0. Well, if the remainder was 0, that should mean that the function has a value of 0. And that also means the polynomial has a factor for that same x value. And we're going to see how all that works together. I know that might have been a little bit complicated in that explanation, but we'll go through this. So we're going to show that x minus 2 and x plus 3 are factors of the following polynomial. So here's what we're going to do. First, we're going to set up our synthetic division. 2, 7, negative 4, negative 27, negative 18. And we have x minus 2 as a factor. That means that we're trying to check positive 2 as a 0. So we're plugging 2 in on the outside. Let's do the synthetic division. We end up with 2 times 2 is 4. 7 plus 4 is 11. 11 times 2 is 22. Minus 4 is 18. 18 times 2 is 36. Minus 27 is 9. 9 times 2 is 18. Good news. We got a remainder of 0, right? So that means the x minus 2 was indeed a factor. Now, here's a fancy way that you can extend your synthetic division. So since we're now trying to check the x plus 3, let's just kind of ignore that remainder and continue the synthetic division from where we left off. So if x plus 3 can be divided by the original, it should also be able to be divided by our new answer, right? Think about if you start with a number like 12, that's divisible by 3. Well, if you divide 2 out of 12, you get 6. That 3 is still in there, and you can still divide by 3. So just like that, we took out the x minus 2. Now let's see if we can take out the x plus 3 from what's left over. So now we have a negative 3 outside to represent the x plus 3. And we don't include the 0 because that was the remainder from the previous step. So our synthetic division is going to be a little bit shorter this time. First, we take down the 2. 2 times negative 3 is negative 6. 11 minus 6 is 5. 5 times negative 3 is negative 15. We get 3. We get negative 9. And we get 0. So boom, we have a remainder of 0 again. So that's good. That means both of these were factors. And we know that we're left over with 2x squared plus 5x plus 3. All right, so the last thing I wanted to show you here is that that means that our original function can be rewritten with an x minus 2 factored out and an x plus 3 factored out. And here's what's left over, 2x squared plus 5x plus 3. Okay? Now that's going to come into play when you get to the worksheet. So that was the end of the notes. I'm going to briefly show you the back of the worksheet so we can see how that goes into play on the worksheet. So if you look at 13 and 14 on the worksheet, it gives you a polynomial. It gives you one or more factors. So this question says we have factor x minus 1 and x minus 3. Factor completely using synthetic division. So we're going to do the exact same thing that we just did, 2 cycles of synthetic division to factor out x minus 1 and x minus 3. And whatever is left over will be left over. Factored form. So in this box, you should have x minus 1 times x minus 3 times whatever you had left over at the end of the synthetic division. Then when you get to the graph, we can actually roughly sketch a graph of this based off of what we just did. So if we know x minus 1 is a factor, that should tell us one of the zeros on the graph is positive 1, right? X minus 1 means that positive 1 was a 0. X minus 3 means that positive 3 is a 0. Then, based off of the original and whatever's left over, we can maybe figure out a couple more things about this. Okay, so maybe you can think about end behavior, right? This is 2x cubed. So as the leading term. So what is that leading coefficient and that degree tell us about the end behavior of this graph? Feel free to check your work on a calculator to check your rough sketch to see if it actually makes sense. The y-axis has no numbers on it on purpose because this rough sketch is not going to know anything about the y values. All we're going to know about is end behavior and x-intercepts. So do your best with that. The graph is not included in the answer key, so you can check on a calculator if you want. But we can always go over this next time we have class if you'd like to do that as well. All right, so let me know if you have any questions. Oh, I did want to say one more thing, and that is that number 14, notice that this says multiplicity 3, meaning the x minus 3 can be factored out 3 different times, and our final factored form is going to have x minus 3, x minus 3, x minus 3, and then something, okay? So you're going to divide out x minus 3 times using synthetic division. Okay, so that's what we got. Again, let me know if you have any questions, and I wish you the best success possible. All right, see you later.